Welcome to 7.3, Exterior Angles and Inequalities. Okay, so let's talk about the definition of an exterior angle, or just exterior. In general, we first need to know it means on the outside of something. And let's bring a little bit of Bible into our geometry again. We haven't done that in a few sections. 1 Samuel 16:7 says, "Man looketh on the outward appearance, but the Lord looketh on the heart." So while God can only judge men justly, we're also to evaluate people's salvation by their exterior fruit. It says that in Matthew 7:15 through 20. You know, when someone says, well, where's the fruit of your efforts? Right? So anyway, an exterior angle is the angle on the outside of the triangle. It forms a linear pair with one of the angles inside the triangle. So here's a triangle, and if I were to extend any of these segments, I would have an exterior angle. So angle 4 is on the exterior in a linear pair to angle 1. So is angle 5. Depends on which segment you are extending. Likewise for angle 2 and 3. Okay, so the next definition is the remote interior angles of an exterior angle are the two angles of the triangle that do not form the linear pair with the given exterior angle. So here we have our extended linear pair to angle B. Okay, the remote, this would be the exterior angle. The remote angles are the other two angles in the triangle. Okay, so now we know all the pieces and parts if we have an exterior angle. Alright, so the exterior angle theorem says the measure of an exterior angle of the triangle is equal to the sum of the measures of its two remote interior angles. Okay, so let's practice this theorem. The way we already know how to do is we would find the angle ONP by taking 180, because we know 180 is the sum of all the interior angles, and we would subtract off the other two angles. So if I took 180 and I subtract off 87 and I subtract off 42, I get 51 degrees. So that would give me ONP, but it says find the measure of angle MNP, which is the exterior angle. Well, I know that ONP and MNP are linear pairs, so they total 180. So I would take 180 minus that 51 degrees, and I would get 129. That would be the old way. Using the theorem, the exterior angle theorem, I will take the 180. Oh, I don't even need 180. It says it totals up those two angles. So if I add 87 plus 42, I get 129. So you have an old way, you can check your answer, and you can actually just add those interior angles that are the remote angles, and you will get the same as the exterior. Okay, so in your notes, I want you to add 3 different triangles. I want you to draw one exterior angle on each one of those triangles. And using a protractor, I want you to measure each of the interior angles, the remote interior angles and the exterior, and see if the measures add up for me. This I'm just going to check when I do your watch section, so you don't have to submit this to me through email. Okay, this is just something I want you to do as an exercise to see if it's true, basically, if this exterior angle theorem is true. So write the measure of all the interior angles and the measure of the exterior angle, and see if the exterior angle theorem is true. Okay, so the last theorem is the exterior angle inequality, and it basically just says that the exterior angle is going to be less than one of the remote interior angles. Okay, I'm sorry, it's going to be greater than. How about I read it? It'll be greater than one of the remote interior angles, which makes sense because it's a sum of two. So two angles, add them together, you get the exterior. Of course, the exterior is going to be more than just one of them by themselves. Okay, so for your whisk summary, I just gave you 3 practice problems so that you can just practice using these theorems. So the next 3 slides are what you're going to submit to me, just 3 numbers and degrees, and I will see you in class.